All right, welcome to our second video of our 6th unit. This one's talking about balancing half reactions. Well, more so balancing reactions using half reactions. So, once we've identified which atoms are oxidized and which are reduced, our next goal is to ultimately balance the equation we're dealing with. So, the issue is that we have to balance both the atoms and the charges. We already know how to balance atoms. That's just your typical balancing equations, coefficients, etc. We got to actually keep in mind all the electrons that are transferred, however. So here's a procedure that's pretty long, but will help. First off, divide our equation into half reactions. So a half reaction consists of only the substances involved in oxidation or only those involved in reduction. You will have an oxidation half reaction and a reduction half reaction. Keep in mind, oxidation is when your oxidation numbers increase. A reduction is when your oxidation numbers decrease. Okay? As a reminder, though, also, if one atom in a molecule is oxidized, then we need to write the entire molecule in the equation in our half reaction. Okay? So first step, make half reactions. Secondly, we got to balance each half reaction. So first off, balance everything just like your normal coefficient balancing, except H and O. So anything that's not hydrogen or oxygen, balance that first. Now, we balance the atoms of O by adding H2O. It's actually a liquid. So we're adding water wherever we need oxygen. So if we have too much oxygen on the left, we add water to the right. If we have too much on the right, we add it to the left. Okay? Once we've balanced using water, we now add H plus wherever we need hydrogen. Typically, you're going to be adding H plus on the opposite side of water because water is going to be adding 2 H's. That's also why you do water first, not H. Otherwise, you have to kind of go back and retrace your steps. Finally, we look at our charges. One of the sides will have too high of a charge. So we add electrons to that side. Keep in mind, they have a negative charge. So for example, if we find that on the left side we have a 2 plus, and the right side we have a total of 5 pluses. That means we need to add 3 electrons to this side, because then 5 plus a negative 3 will get you 2. Okay, or if we had, I don't know, 2 minus and 3 minus, then we would need to add 1 electron to this side, because 1 minus plus 2 minus will get us 3 minus. So, balance everything besides H and O, balance O, balance H, balance charges. Now, we need to multiply our half reactions by integers. Basically, they need to give and take away the same number of electrons. So, if one of them is adding 2, has 2 electrons, and the other has 3, then they need to both get to 6. So, 2 and 3. Then this one needs to times by 2, this one times by 3. You can basically just multiply each other by the other number, but if one's doing 1 and the other's 2, we just need to double this. Or if one's doing 2 and the other's 4, we just need to double this. We don't need to, instead of multiplying this side by 4 and this side by 2. Anyways, make sure they have the same number of electrons being transferred. All right, now we combine them. So add all your reactions together, your products together. If the species occurs on both sides, then we just cancel it out. You know how to do that. And your electrons should always completely cancel out. If they don't, then you didn't do the previous step. You didn't make sure they're transferring the same number of electrons. But anyways, combine your reactions. Fifth, if you're in basic solution, typically you're in acidic solution, and it'll tell you every time. Normally, the previous step is your last. However, sometimes they say basic. So basic means that you shouldn't have any hydrogens left over, because you're not an acid, you should have hydroxides left over. So for every hydrogen that's left remaining, add a hydroxide to both sides. Okay? Then, on the sides where you have both, turn them both into water and cancel out if necessary. But you should end up with all your H's neutralized, and you'll have an excess of hydroxide. That's only, again, if you're in basic. All right, let's practice this really long kind of sort of ish problem. So first, we got to split them into half reactions. Oxidation, we got -1, +3. This one to be in a 0. And to be honest, right away, I actually know what's going to be reduced and stuff, but we'll finish this anyways. So we got -2. That'll give me a -14. That means that's +12. That means that'll be a +6. All right, so my oxidation is then going to be Cl minus 2Cl2 as a gas. Well, technically as a gas. Okay, I'm going to work on oxidation first because this is going to take a lot of room. Okay, I need to balance everything besides H and O. The only thing I really need to do is put a 2 there. Now I add oxygen, I don't need it. Hydrogen, don't need it. So I look at electrons. I have 2 negatives over here, no negatives over here. That means this will be +2 electrons. Yay, we're done. Okay, reduction. I'm actually going to put that down here. It's going to be everything else. Cr2O7 2 minus produces Cr3 plus. Okay, I have 2 chromium over on the left, so I need 2 on the right. I have 7 oxygen on the left, so I need to add 7 water. That means I need to add 14 H's. And now I've got a 2 minus plus 14 positive. That's a 12 positive. 6 positive plus 0. That means I need 6 electrons over here. Okay. So when I combine them, I have 2 electrons, 6 electrons. That means this all has to multiply by 2. That'll get me 6 chlorine, producing 3 chlorine plus 6 electrons. Now I combine everything. So I have 6 electrons plus dichromate plus 14 H positive plus 6 Cl negative produces 2 Cr3 plus 7 H2O plus 3 Cl2 plus 6 E negatives. The only thing that cancels out are my E negatives, and that is my balance equation. I cannot believe I fit that on one slide, and I barely did. You're probably going to want to rewatch this again for in class. Obviously, feel free to. If you're at home, I highly recommend it. But that is how you balance half reactions, and yes, they will kind of always take that much room. So there you go. All right. This one I'm going to let you try, but I'm kind of going to do that in steps. So first, I'm going to work and show you basically the balanced half reactions. Then I'm going to show you the actual combined reaction. Then I'm going to show you what you do to actually finish it because it is basic instead of acidic. So go ahead and pause the video. Try it. When you've got both half reactions balanced, then press play. I'll show you that, and you'll, etc., do it in steps. So get working. All right. So here's the oxidation and reduction reactions. Notice you got 1 water, 5 H's, and 3 electrons. 4 H's, 2 electrons, and 2 waters. You also need a 2 over here to get the 2 chlorine. Okay, so now that you've got this, go ahead and pause the video. Come back in a minute, and I'll show you what happens when you combine these and balance it in the process. So, go and pause the video and come back. Alright, so this is our balanced reaction. I underlined these to show you these are all reactants and these are all the products. You will notice there's random coefficients. Well, hopefully you won't think of them as random. We had to double our first equation and triple our second when we add them together because we needed a total of 6. But there you go. That is our reaction. Now, if we were in an acidic solution, we'd be done. Okay? The issue, though, is we're in a basic solution. And the rules say that basically for every H plus, you add an OH minus to both sides, turn them into water, and then cancel out as necessary. So I'm going to say pause the video, try that, come back in a bit. All right, and here's our balanced equation. We had to add 2 hydroxides to both sides. That actually canceled out both of our reactants. Well, turn them into water, and then we were able to subtract water from both sides. We ended up with 2 on the right. And you'll notice this thing is balanced. We've got, again, a 6 negative charge on the left, and we have a 4 negative plus a 2 negative for a 6 negative on the right. Add them to balance as well, and there you go. That is how you balance that equation by the method of half reactions. Yeah, thanks for watching. Definitely feel free to watch again. They can take quite a bit of space, and good luck.